Today we're going to look at finding an angle using trigonometry. So inverse trigonometric functions can be used to find an unknown angle in a right-angled triangle. So if I've got a right-angled triangle here, I can use the fact that the different trigonometric ratios are constant with the specific angle to actually determine what that angle is. So if I know that sine of the angle is opposite over hypotenuse, and cosine is the adjacent over hypotenuse, and tangent is the opposite over the adjacent side, I can use these inverse trigonometric functions. So these are inverse sine, inverse cosine, inverse tangent trigonometric functions. And the relationship between them is, if I'm looking at the sine of the angle, that angle is the opposite over the hypotenuse. If I want to find that angle, if I want to determine that angle, I can use these inverse sine functions, or the inverse sine function, or the inverse cosine function, the inverse tangent function, depending on which sides I have to work with, or which sides I know. Now these inverse trigonometric functions can be found on your calculator, often by pressing the second sine button, second and then sine, or shift and then sine, something along those lines. So if you know what the ratio is, the ratio of the sides, then we can determine what the angle is. And the reason we can do that is because we understand exactly what the ratio is at each different angle. So it's essentially what the calculator does is it works backwards to determine what that angle is if we know what the lengths of the sides are. So if we look at a quick example, to find the value of theta in this triangle to the nearest degree, all we need to do is we need to firstly determine which function we need to use. Then, because we've got the lengths of the sides, we know the lengths of the sides, we can use the relevant inverse trigonometric function to determine the angle. So I have got the hypotenuse here, we've got the hypotenuse, and we've got the side that's opposite the angle, So because I've got the opposite and hypotenuse, I know that I need to use the sine function, the sine ratio. So I can firstly start out by writing the definition. Sine of theta is equal to opposite over hypotenuse. Then I'll find show that I'm going to determine the angle by finding the inverse, using the inverse trigonometric function, which is the inverse sine function. So inverse sine function of the opposite divided by the hypotenuse. So the opposite side is 6 in this case. Hypotenuse is 10, so all I'm doing now is substituting in values. Then all I need to do is type into my calculator second or shift sine to get the inverse sine function, and then open brackets and put inside the brackets 6 over 10, or 6 divided by 10, closing the brackets off, and then if I press enter on my calculator I get around about 37 degrees. It won't be exact, but we've been asked to round to the nearest degree, and to the nearest degree our angle here is 37 degrees.